Hello everyone, today we're going to look at 3x3 determinants. You're still going to have to look at the book to use Cramer's rule in solving 3x3 systems, so we're just doing the determinants part today. A 3x3 matrix looks like the following. So again, it's 3 rows, 3 columns, so there are 9 elements. And just like with the 2x2 matrices, the determinant looks like the matrix, except instead of brackets on either end, it's more like absolute value signs. Before we can talk about the determinant, though, we need to have a couple of definitions. The first is the minor. The minor of an element of a matrix is the determinant of the resultant matrix found by deleting the row and column of the element. So I'll show you what I mean in an example. In the following matrix, find the minors of the elements 1, 3, and 0. So I'll start with the element 1. So here's my element, and if I want to find the minor, I am going to delete the row that contains 1, and I'm going to delete the column. The marker doesn't want to work right. There we go. So I delete the row and the column that 1 is in, and what I'm left with is now a 2x2 matrix, and I want to find the determinant of that 2x2 matrix. So if we remember, if I have the matrix, say A, B, C, D, then the determinant, is A times D minus B times C. So to find the minor, I am going to find the determinant of -1, 2, 2, 2. So I have -1 times 2 minus 2 times 2, and again, I'm getting rid of the row and column. And that gives me -6. If I want to find the minor of the element 3, again, I'm going to delete the row and the column, and I'm left with the matrix -2, 4, 2, 2. And to find that determinant, I multiply -2 and 2, multiply 2 and 4, and subtract. And that gives me -12. Lastly, I'm going to look at the element 0. Again, I will delete the row and column that 0 is in. I have left a 2x2 matrix. I find the determinant. So I have -2 times 2, 4 times -1, and that gives me 0, which is just a coincidence. Okay, so that's how we find the minors. Next, we're going to look at the cofactor. So the cofactor of an element is -1 to the I plus j times the minor. I and j are the row and column of the element that's inside the matrix. The rows get counted from top to bottom, the columns get counted from left to right. So I'm going to use that same matrix I just had, and instead of finding the minors, I'm now going to find the cofactors of those same elements 1, 3, and 0. So again, I'll start with element 1. That is going to be -1 to the 1 plus 1. 1 is in the first row and the first column. The minor, remember from the last slide, was -6. Remember order of operations, I need to add the 1 plus 1 first because that's in a parenthesis that you don't really see. So I have -1 to the 2, that's +1, times -6 gives me -6. So the cofactor is always either the minor or the negative of the minor, depending on if I plus j is even or odd. If I plus j is odd, -1 to an odd power is -1, so the cofactor would be negative the minor. And if I plus j is even, then -1 to an even number is 1, and the cofactor is the minor itself. So let's try this again with 3. 3 will be -1 to the 1 plus 2. It's in the first row and the second column. So I and j are 1 and 2. It doesn't matter which one you consider to be the row, which one you consider to be the column, because you're just going to be adding them together. And if we remember, the minor from before was -12. So I add my -1 to the 1 plus 2, which is -1, times -12, and I get 12. And I'll do the same to 0. It's not really going to matter because the minor was also 0, but for the sake of completeness, 0 is in the first column, third row. So it would be negative 1 to the 1 plus 3 times 0, which is 0. Okay, so we've done a minor, and now we've done the cofactor. And that brings us to the determinant. So the determinant is the sum of the products of the elements with their cofactors for any row or column of the matrix. So I pick a row or a column, doesn't matter which one, and then whatever row or column I choose will have 3 elements. I'm going to take those elements, multiply them by their factors, and then add them together. So again, taking the same matrix from before, I'm going to find the determinant. I already found the cofactors for the elements in the first column, so that's the one I'm going to choose. So my first element is 1. Its cofactor was negative 6. The next element is 3. Its cofactor was 12. The next element was 0. And again, its cofactor was 0. And if I add all those up, I have negative 6 plus 36. That's 30, and that is my determinant. And again, I could have chosen the first row, the second row, the third row, the first column, the second column, the third column. Doesn't matter which one I chose. Every time I should get 30. So one of the things we want to keep in mind when choosing what row or column is that if I have an element that's 0, I'm going to multiply 0 by the minor or the cofactor, but it doesn't matter what the cofactor is because I'm multiplying it by 0. So if I choose a row or column with a 0 in it, that's one less cofactor I have to actually find. So we're going to see when this comes into play. So here's another example. Find the determinant of the following matrix. So we have negative 1, negative 2, 5, 2, 3, 1, 3, 0, 3. We're going to choose the third row because it has a 0 in it. Notice I also could have chosen the second column because that also has 0. So I'm going to make a little table. The first element in my third row is a 3. It's minor when I get rid of that row and column. I'm going to look for the determinant of that new 2 by 2 matrix, which would be negative 2 minus 15. So that's a minor of negative 7. Its cofactor will be negative 1 to the 1 plus 3. It's the first column, the third row. So I and j are 1 and 3. And that gives me a cofactor of negative 17. Next is the element 0. It doesn't matter what its minor and cofactor are because again I'm going to be multiplying it by 0, so I don't even have to do this. So I move on to my last element, another 3. So again, I delete the row, I delete the column. I have a new 2 by 2 matrix. And when I look at that's determinant, it's going to be negative 3 plus 4. So its minor is 1. That new 3 is in the third row, third column. So I have negative 1 to the 3 plus 3 times the 1 from the minor. And I get 1. So for the determinant, I have my element 3 times its cofactor negative 17 plus 0 plus my element 3 times the cofactor of 1. And I get out negative 48. Okay, and again, no matter what row or what column I chose, if I do it out correctly, I should get negative 48 every time. So let's try another example. So now we have the matrix 2, negative 2, 3, 1, negative 3, 2, 1, negative 1, 4. Notice there are no zeros in this matrix, so it really doesn't matter which row or column I choose. So I'm going to choose the second column. Again, we'll make a little table. The first element in the second column is negative 2. So when I delete the row, delete the column, I'm left with 1, 2, 1, 4. The minor of that is 4 minus 2, which is 2. The cofactor, negative 2 is in the first row, second column, so it's going to be negative 1 to the 1 plus 2 times the minor of 2, which is negative 2. The next element is negative 3. When I get rid of that row and that column, I'm left with the matrix 2, 3, 1, 4. And when I find the minor of that, I will have 8 minus 3, which gives me 5. The cofactor is going to look like negative 1 to the 2 plus 2, because negative 3 is in the second row and second column, times 5, which will give me positive 5. And then lastly, the third element is negative 1. So again, I get rid of that row, I get rid of that column. I have the matrix 2, 3, 1, 2, which gives me a minor of 1, the 4 minus 3. Negative 1 is in the second column, third row, so the I plus j is going to be 3 plus 2. Negative 1 to the fifth times 1 is negative 1. And then again for the determinant, I'm going to multiply the elements by their cofactors and add them together. So I have negative 2 times negative 2, which is 4, plus negative 3 times 5, which is negative 15, plus negative 1 times negative 1, which is plus 1, and that gives me negative 10. So let's try another one. So we have the matrix 1, 4, negative 5, negative 2, 0, 6, negative 4, 3, 4. Again, notice I have a 0 in my matrix, so I want to either choose the second row or the second column. Either one will make use of that 0. So we're going to choose the second row since we just did the second column. Again, I have my table. My first element in the second row is negative 2. When I get rid of it, I have 4 and negative 5, 3, 4. So I have 16 plus 15, which gives me a 31. Negative 2 is in the first column, second row, so that's negative 1 to the 3 times 31, which gives me negative 31. The next element is 0. Again, it doesn't matter what the cofactor is, because when I multiply it by 0, I get 0 anyway. So I'll skip that and go to my last element, which is 6. When I get rid of that row and column, I have the matrix 1, 4, negative 4, 3. So I have 3 plus 16 when I find the minor, which is 19. 6 is in the third column, second row, so it's negative 1 to the 2 plus 3 times 19, which will give me negative 19. So for the determinant, I have negative 2 times negative 31 plus 0 plus 6 times negative 19. And that will give me negative 52. Okay, so try out the homework. Don't forget, you're also going to need to look over Cramer's rule before you do the homework. So using the 3x3 system of equations, using Cramer's rule to solve for, say, x, y, and z. So it's very similar to the 2x2 matrices, just there's a third variable, a third row, and a third column in your matrices. So they take a little bit longer, but it's the same process. So try it out, try the homework, let me know if you have any questions.